Liebe Zuschauer, liebe Zuschauerinnen, ganz herzlich willkommen zu einem weiteren Webinar unserer Webinarreihe Bye Bye CO₂. Heute mit dem Schwerpunkt Maritime Infrastruktur, Struktur für CCUS. Mein Name ist Rasmus Portmann, ich bin heute Ihr Moderator. Bevor wir inhaltlich starten, vorab noch 2, 3 organisatorische Themen. Die Veranstaltung oder das Webinar wird aufgenommen und kann dann im Nachgang auf unserer Website und unserem YouTube-Kanal angeschaut werden. Wenn Sie Fragen haben, gerne in den Chat schreiben. Dadurch, dass wir heute ein englischsprachiges Webinar vor der Nase haben, würde ich Sie auch bitten, die Fragen, wenn möglich, auf Englisch zu stellen, so dass ich nicht irgendwie über Übersetzungsfehler die falschen Fragen stelle. Und genau, das war's zur Einführung. Now I will switch to English and want to very welcome to our speakers today. Thank you very much, guys, for joining us. And we will have 3 speakers today. The first one is by Sarah Arns. She is a business manager for CCS from the port of Rotterdam. The second one is Gilles Suppli. He's a policy advisor at Fluxys. And the last one is Kai Becker. He's a business development manager for clean energies at Höegh Evi. And again, guys, thank you very much for joining us. And now we will start with Sarah and her presentation. Sarah, it's your turn.
So my name is Sarah Arns from the Port of Rotterdam. Maybe before I start, it's good to give a little bit of overview of what the Port of Rotterdam is. It consists of a large industrial cluster of 42 kilometers, hosting several industrial companies. But of course, it's also a port for importing and exporting goods and products, not only to the Netherlands, but also to what we call the hinterland. So to give an example of this, 13% of the total energy consumption of the European Union is imported through the Port of Rotterdam. So I will come back to this later, but we also view industrial clusters in Germany or in Belgium as our customers, as our cluster is highly connected to those clusters. So of course we aim to decarbonize our port. It's based on 4 pillars. The first one is efficiency and infrastructure. The second one, a new energy system. The third one, a new feedstock and fuel system. And the fourth one, sustainable transport. And what we actually see is that capturing CO₂ and storing CO₂ or making CO₂ available for usage has a role in all of these 4 pillars. So very specifically, what is the role of CCS for the Port of Rotterdam and the industry that we have here? On the left side, you see our goal to decarbonize current activities. So CCS can quite quickly remove the carbon emissions from current industries, such as refineries or such as the hydrogen production that is already in place here from natural gas, but also the chemical industry and waste incinerations. And on the right side, you see that we also foresee a role of CCS for new value chains, such as the hydrogen transition. Of course, we want to move to green hydrogen, but we definitely see a role for blue hydrogen to make this transition possible. And also we see that companies in the Port of Rotterdam that produce biofuels, for instance, who have not fossil CO₂, but biogenic CO₂, are also interested in capturing and storing this CO₂, because then we create negative emissions or carbon removal. And the last one is the maritime sector. That's really a new one. So we also see that a lot of ships that are coming to the Port of Rotterdam look into onboard carbon capture to make sure that they can capture the CO₂ that they emit during their sail, and then they can offload it in the Port of Rotterdam to permanently store it here. So those are the several sectors that we see that are looking into CCS. So maybe a little bit about the projects that are being either constructed or researched right now around the Port of Rotterdam. The first one is Portos. It's actually being built right now. So we see the pipelines through the port area laying and waiting to be installed underground. So it's an infrastructure project for CO₂ transport and storage. The customers, there are 4 initial customers: Air Liquide, Air Products, ExxonMobil, and Shell are responsible for capturing their CO₂, and they inject it into this public collective pipeline, the purple line that goes through the Port Rotterdam area. On the Maasvlakte, that's the left side on the screen, we have a compressor station who makes the CO₂ from a gaseous phase into a dense phase, and then it goes offshore through the pipeline to an offshore depleted gas field for permanent storage. So it will be operational next year, 2026, and then store 2.5 megatons of CO₂ each year for 15 years till the field is filled. So these are some pictures of the construction phase: onshore the public backbone, and offshore the injection well that's being prepared. So the second project that is being prepared is the Aramis project. It's not onshore, but only offshore. So it's an addition to the offshore storage capacity, an offshore pipeline from the Maasvlakte to new fields. They will make use of the landline and the compressor station of Portos. And the parties who are developing it are Gasunie, EBN, Total, and Shell. And the volumes that can go there are, as I said, from the Portos onshore backbone that we just saw, but also from CO₂ Next, which is an import terminal for ships. So for clusters or emitters that are not connected to a pipeline, they can bring their CO₂ by ship to CO₂ Next to inject it in Aramis, but also the Delta Rhine corridor going up to all the way to Germany, and the Delta Schelde connection, aiming to make a connection to Belgium. And the capacity is much larger. So this pipeline has a capacity of 22 megatons per year. So this is really preparing to facilitate not only CO₂ storage from the Rotterdam area, but also from other clusters bringing their CO₂ to Rotterdam. So this is how it looks like. The Portos landline is the first stage, now adding CO₂ Next and the Aramis offshore trunk line and new storage fields. So maybe a little bit about the role of Port of Rotterdam within Northwestern Europe. We did a study together with EBN and Gasunie about the potential in terms of CO₂ storage facilities, but also the expected amount of CO₂ being captured in several industrial clusters in Germany, north of France and Belgium. And we did a study to see what the most cost-effective network would look like. Of course, there are many studies like this, but we found that it is for the southeast of Germany and Belgium most cost-effective to bring the CO₂ towards Rotterdam as a central exit place to store it on the North Sea. And then for the northern part of Germany, you see that it's more cost-effective to go to the Nordics for their storage. So this is a slide from Gasunie, actually not from the Port of Rotterdam, but we see that what we found in the study is actually being translated into concrete projects right now, such as the Delta Rhine corridor, Delta Schelde connection, and the other projects that I mentioned, all coming together in the Port of Rotterdam. And of course, that takes a lot of space, so it's quite a challenge to fit everything into the pipeline corridors that we have in the Port of Rotterdam. But as I said, we see our role not only to decarbonize the customers that are located in the Port of Rotterdam, but also for clusters that are located in Germany or Belgium, and to facilitate a cost-effective CCS network for all the industry in Europe. A little bit about the roles that different parties play till now in the development of CCS in the Netherlands. So for Portos, we really had a public-private partnership. So the infrastructure and storage is totally developed and provided by state-owned companies, being the Port of Rotterdam, EBN, and Gasunie. And then the private companies invest in capture and pay for the transport and storage, and the government, the local government, provides the funding that is needed to build a business case for these private companies. And the reason that is needed is that we see that the costs of CCS, of course, this really depends on the type of capture and the amount of skill that we find, but it varies between 80 and 210 euros per ton CO2 to capture and to transport and to store the CO2, while the ETS price, so the price we pay to emit, is currently, I think, about 70 euros per ton. So the Dutch government has a subsidy scheme called SDE++, which, well, it has some drawbacks, but in generally it works quite well. It covers the price gap between the costs for CCS and the costs of emitting CO2. So this way, it gives certainty to emitters that capturing and storing your CO2 is always cheaper or more cost effective than emitting the CO2. So what I said is that in the first project, Portals, it was fully provided by state-owned companies. And now in the next project, Aramis, we are moving more to a private public mixed proposition. So the transport is still in hands of the state-owned companies, which makes sense as there's not much competition possible, right? It's more cost-effective to build one large pipeline than competing on this part. But for the storage part, we see a role for the private companies such as Shell, Total, Eni, developing stores and also competing with each other. So emitters have optionality to which store they go, and then they use the public-owned transport part to get there. Some challenges maybe which we see, always the long term versus the short term. So in the long term, if all the CO2 volumes develop as we expect, it makes absolutely sense to build bigger pipelines. It gets much cheaper if you have much more volume. But on the other hand, we also need projects to get started, and therefore you need a certain amount of launch volume, the first customers, and the larger you build, the more difficult it is to actually get started and have an initial business case. So this is an ongoing challenge in which the Dutch government is also supporting, for instance, Aramis to cover a bit of what we call the underutilization risk. The second one is the fragmentation of projects. So you saw that Aramis is connected to Portals, that the Rhine corridor will be connected to Portals and to Aramis, and every part has a different composition of shareholders. And it's great that we see it really developing into one network, but it also brings a lot of challenges in making sure that everything is integrated well and that we have a clear story to customers and emitters. And the last one, the typical chicken and egg in tariff setting. So the companies investing in infrastructure need to know their volumes to set a tariff, but the customers need a tariff to say whether they are going to provide the CO2 or not. So this is also a typical challenge that we have. That's it for now.
Thank you very much. Very impressive insight, and nice to see these ambitions on CCUS in Rotterdam. Thank you very much. And yeah, then we will continue with the next one. Gilles, it's your turn. Thank you very much.
First of all, thank you for inviting me as well to contribute to the webinar. So I am Gilles Supply. I am Public Affairs Advisor at Fluxys, and I'm going to give you a preview of what we're doing on CO2, and also some insights as well on the regulatory framework in Belgium, and linked to that, of course, certain challenges we see from a policy point of view, which Sarah also mentioned to a certain extent. But before I dig into CO2, perhaps also a brief introduction on Fluxys. So Fluxys is a multi-molecule infrastructure group headquartered in Belgium. So we're a Belgian company, but with quite a big footprint in particularly Europe, but also in South America, and a small share as well in our colleagues in Oman. And we have three main activities. So we have investments in LNG terminals, The most well-known ones, I would say, definitely for this audience, would be the one in Zeebrugge and the one in Dunkirk. But we also have stakes in the LNG terminal in Quintero, Chile, and in Rivitausa, Greece. Then, of course, transmission itself, so the pipelines we operate, or we have in our portfolio 28,000 kilometers of pipelines, natural gas. And then also a very small, definitely from a German perspective, quite a small storage site, which is nevertheless quite important for the security of supply in Belgium when it gets cold. We employ about 1,300 people, and we are definitely looking at the future because we are fully engaged in building out activities in both the transport of CO₂ and the transport of hydrogen. Very quickly, also on our role for the security of supply of Germany. Zeebrugge is a very important import hub for natural gas because we combine lots of different import capacities over there. Pipeline connecting Zeebrugge with Norway, a pipeline connecting UK with Belgium. And then you have, of course, the LNG terminal in Zeebrugge. And the LNG terminal in Dunkirk is also directly connected to Zeebrugge, which more or less gives an import capacity of 19 gigawatts, which is very important for Germany because of the 407 terawatt hours in 2024 that we imported. 259 were for transit activities, of which Germany is quite important. You see here 154 terawatt hours directly going to Germany. But also the part going to the Netherlands very often ends up in Germany. So we play a pretty important role in the security of supply of Germany with regards to natural gas, all the more so over the past couple of years. And I'm showing this slide because this is also definitely something that we want to replicate for CO₂, but then of course in the other way around, instead of importing natural gas towards Germany, we want to also have your CO₂ and export it towards sinks. But then let me dig into the CO₂ file, of course. So first of all, the whole regulatory setup. I think it's safe to say that in Belgium, the regulators or the policy framework were front runners because we have already a regulatory framework as of March 2024. In Belgium, CO₂ transport is a regional competence because of the fact that CO₂ is considered as a waste. And because of that, it's a regional competence, which means that we have two frameworks in Wallonia and in Flanders, but they're very much aligned on each other. And I think it's important to note here that one of the key elements of this regulatory framework is that one CO₂ network operator is appointed by the government, who is then responsible for the development of a network, which I think Sarah already mentioned it, also makes sense because it's kind of a regulated monopoly. You want to have an efficient development of a CO₂ network because it would be rather inefficient to start building out parallel networks. So it's a regulated monopoly where we established Fluxys Sigrid as a candidate to become a CO₂ network operator in both Flanders and Wallonia. And we expect to have a nomination in July, September this year. So we expect a nomination soon. And I think another important element here to mention is also that Belgium already ratified the amended London Protocol. I think it's also on the agenda in Germany, which allowed us to already start negotiating bilateral arrangements for the cross-border transport of CO₂. Only Norway is mentioned here, but we also have one with the Netherlands, and we have one with Denmark as well. But I think definitely the Netherlands and Norway is important for the audience here. So if you look at the vision we have in mind with regards to the development of a CO₂ network in Belgium, I think two main characteristics. On the one hand, we aim to aggregate CO₂ volumes from big industrial clusters inside Belgium on both sides of the linguistic border, which is the red line. So this network would allow us to indeed aggregate all the CO₂ volumes. And then on the other hand, the yellow reddish line is a dedicated pipeline for German CO₂ emissions, connecting Enatten all the way to Zeebrugge, where we're also looking at the development of several exit options. Apart from that, as I already mentioned, so in 2023, together with some local partners, we established Fluxys Seagrid. In 2024, we also launched a call for market interest, where there was also quite some interest from German emitters. And in 2025, we also received CEF funding to start studies on the development of the dense pipeline, which is the one connecting Enatten with Zeebrugge. And more as a general statement, so the ambition of the Fluxys Group is to offer a CO₂ transport capacity of 30 million tons by 2030, on the Fluxys Group level, that is. The chicken egg challenge has been mentioned before, but I think it's important indeed to also mention here that we take up responsibility as a network operator, and we also started constructions of the CO₂ network with a focus on cluster Antwerp. So there we already started developing the first CO₂ pipelines, which could be linked to the Antwerp at Sea export terminal project. Of course, what's in the name, in the Port of Antwerp, where we are co-developing with Air Liquide and Port of Antwerp Bruges the development liquefaction terminal to liquefy CO₂ and then transport it via ship. The initial capacity of this export terminal would be 2.5 million tons of CO₂, mainly for emitters in the Port of Antwerp, but on the basis of market interest, this could be expanded up to 10 million tons of CO₂. Zeebrugge is important for us as well. Let me start with that, where we are currently in very close cooperation with Equinor and OG as well for the development of an offshore pipeline all the way going to sinks in Norwegian waters. It's a large-scale solution because the idea would be to have a capacity of the pipeline of 18 million tons of CO₂ in the first phase, but that can be scaled up until to 27 million tons of CO₂. It's a very important project for us. It already got PCI status and CEF funding. We're also, however, looking at a connection with UK. So we have a project called Carbon Connect, which is currently being developed or structured by our subsidiary Interconnector, which is a subsidiary responsible for the offshore pipeline operation between natural gas between United Kingdom and Belgium. We are looking for PMI status. We are on the draft list, so we are quite hopeful that we will get PMI status, project of mutual interest. And then, of course, as already mentioned also by Sarah, we're also looking at a connection with the Netherlands. So there are quite some exit options connected to the Belgian grid. Maybe an important remark with regards to the challenges we see. So we are basically a midstreamer. We provide the network, and there are three, I think, important challenges. Of course, on the one hand, the asset integrity, which for me is also to a certain extent linked to the interoperability. But asset integrity relates to, of course, for example, the specs. So we have to make sure that specs are right and work for everybody. I think that's quite important. And of course, interoperability also relates to specs again, because you need to have an alignment on the specs between the different operators to ensure that we can have one interoperable cross-border network, which is very important. And then you have the system cost efficiency. We also believe that indeed the idea of having one nominated network operator allows to have a cost-efficient system rollout, which is quite important. But I think in the end, cooperation between the three main players in the ecosystem is important. That is the industry, Fluxys as network operator, and authorities to overcome certain challenges, because we believe, of course, that large-scale solutions will require in the first instance an important role for the authorities to smoothen out the issues or challenges we face during the ramp-up phase, to be able to offer, of course, competitive tariffs to industry. And for that, we are in close collaboration with our governments, who also place CCUS as an important way to decarbonize the industry on the policy agenda. Voilà, I think this is the last slide. It's a general idea of how we see things. So as I mentioned on the first slide, We currently play an important role as an import hub for natural gas, key for the security of supply of Northern Western Europe. We aim to replicate this role in the future energy system by also positioning ourselves as a hydrogen hub, also for Germany. And then, of course, related to this webinar, CO₂, we also want to position ourselves as an important hub for this evacuation of CO₂. We are very much looking forward to also collaborating with Germany, and this is already the case with a very close collaboration with our German counterparts, OGE and Gascat. I'll leave it at that, and I'm happy to answer any questions from your side.
Yes, Jill, thank you very much also for this insight and for the insight in your activities. Very, very interesting. And yeah, the next and last one, last speaker will be Kai Becker from Höegh Evi. Kai, it's your stage.
Thank you, Rasmus. Thank you, Sarah, and thank you, Jill. Very, very interesting indeed. My name is Kai Becker. I'm the Business Development Manager for Clean Energy Solutions at Höegh Evi, and especially responsible for developing the German market. Let me just give you a short introduction to Höegh Evi. We were formerly known as Höegh LNG. We are a maritime company by nature. Our principal management offices are located in Oslo in Norway. We have about 100 years experience in shipping and decades in maritime energy supply. EVI, by the way, stands for Energy Vector Infrastructure, and that shows a little bit that we are moving away in the wake of energy transition from our traditional business and energy supply, which is LNG, and our floating storage and regasification units, short FSRUs, of which we are operating 10 worldwide, and also to mention 3 of them in Germany, in Wilhelmshaven, Brunsbüttel, and Mukran. And the new vectors we are following up with now is the import of ammonia and hydrogen and the export of CO₂. So for that, we have been entering into new designs. So on the hydrogen and ammonia part, we have been developing our own cracking technology together with Wärtsilä. We've also been developing floating hydrogen and ammonia import terminals, and now coming to CCS. The other way around, CCS shall be exported and stored away permanently on the Norwegian continental shelf. And also for that, we have created our floating solutions. For that, we have been partnering with AKBP. AKBP is the largest independent exploration and production company on the Norwegian continental shelf. They have 2 licenses been awarded, which are called Poseidon and Atlas. Both of them located off the western coast of Norway. And both storage fields will handle about 6 million tons of CO₂ per year, but are expendable to above 10 million tons per year. What we're planning to do is to really offer a one-stop and state-of-the-art solution with, of course, going to scale, offering flexible concepts, such as we have also with our FSRU, since floating solutions will be able to be relocated when they are better served at another site. And we plan to be an early mover. So our ambition is to be online with our solutions by the end of this decade. What does the value chain look like that we cover? So as I said, we are a maritime company by nature. So we naturally start at the port, where we will collect, store immediately, and offload the CO₂ onto shuttle carriers, which will then go out to the injection fields and via direct injection store CO₂ permanently in the storage fields of Poseidon and Atlas, as I explained before. Let's take a closer look at our floating collection, storage, and offloading unit. I know it's a long name. We tend to do that. So we have a nice abbreviation, which is FCSO. The goal is to really intermediately store the CO₂ that the vessel will receive, from various sources. So it will be able to handle gaseous and liquid CO₂ in different qualities, coming from either a pipeline system, but also via rail, truck, barge, or ship. The FCSO will be able to condition that CO₂, meaning we will have compression units, purification units, and liquefaction units aboard to basically condition it to the quality and aggregate that we need for further transport on the shuttle carriers. In terms of volumes, we are talking in between 40,000 to 80,000 cubic meters at low pressure, which can be stored on these units. And as I said, the CO₂ will be offloaded to shuttle carriers, which kind of look like that. I mean, there also has been a press release lately. We have received approval in principle for DNV for those shuttle carriers or tankers. They will come in two sizes. One is about 37,500 cubic meters of tank capacity. The other one, 50,000 cubics. As I said before, we are preferring to store and transport at low pressure, simply because it will allow us to handle larger volumes. For that, we have IMO Type C tanks. Pressure is about 8.5 bar at minus 47 degrees. We are still looking into other materials as well, but this seems to be the most viable option for the moment. What will happen then? The ships will go out to the injection site and directly inject into the subsea storage field. Therefore, the CO₂ needs to be reconditioned again, meaning we need to put it to a higher pressure, and we also need to warm it up to be ready for injection. The shuttle carrier itself will use a single anchor loading system, meaning it will be offshore moored right above the injection site, and then will connect to the subsea system and the wells, and will inject the CO₂ directly then into the storage fields. That takes about 2 to 3 days at a time. There will be several shuttle tankers operating per floating terminal at a given time, to make sure that we have a continuous flow and continuous operations to the storage field. Just a little bit of illustration on how that looks like. We are using in Norway saline aquifers for storage, not depleted oil and gas fields. There is a potential there for that in Norway, but so far the Norwegians have not come along with that. So all licenses that have been awarded so far deal with saline aquifers. From the location of the sites that we have, we are expecting a very high rate of operation. So very few days only during the year where we won't be able to inject. And thus, of course, building up a very efficient and also very cost-effective solution for our customers. Of course, as was mentioned before by Sarah and Gilles, it's very important to get up to scale at some point. So while we are able, as I said before, to collect, from various kind of sources and in different kind of qualities, and also in smaller volumes. At the end, of course, you're looking for larger scale operations. And that means, in particular, that a transport via pipeline to our floating terminals, is in the end a very preferred and also very necessary option to get to the large volumes that we really want to get rid of in the end. As I also said, we are quite ambitious with it, so we want to be operative by 2030. And from our technical expertise that we have, and from the studies and the tests we have done, we are very, very confident that it's possible to do that from the technological level. Of course, what we need then is a market that appreciates that, and also, of course, has the right regulatory framework for emitters to jump onto the solutions that are offered, for CCS, including, of course, the ones that Sarah and Gilles have pointed out before. Because one thing I think is clear: we have a lot of CO₂ in the atmosphere right now that we need to get rid of, and there are several solutions available. And from my personal belief, I think we will, in the end, need as many of them as we possibly can put into action. Thank you very much. I think I'm maybe a little bit ahead of time, but that leaves more room for questions, I suppose.
Yes, Kai, also thank you very much for the insights, and again, Sarah, Gilles, and Kai, thank you for the overviews and insight in your projects. And I think they are a very, very good example how ambitious our European neighbors are in the case of CCUS. And that means that we are in Germany a little bit behind, and I think it's a good signal that you are developing these projects and these activities. I think this is a very, very important message. And I mean, you are not the only ones. You are just 3 examples of this big CCUS projects. We have some in UK, others in Norway and Denmark and stuff like that. So yes, very, very interesting. And yeah, we get a lot of questions. I try to manage it, and we'll start with the questions to Sarah. The question is if the Dutch political framework differs between the CO₂ sources. Are they restrictions like CO₂ only from hard-to-abate sectors, or are there other restrictions on it? Because in Germany, maybe as you know, we have a discussion about it, what kind of CO₂ we are want to manage or want to store or to use.
Yeah, so there are no restrictions on who could apply CCS. However, the subsidy scheme, SD++, which almost every sector would need to build a business case, has categories for the type of segments or sources that can apply. So, for instance, you cannot apply if you want to use CCS for a coal-fired plant, and for biomass, there's a limit in the scale. But most other categories are included. Sometimes that can be a challenge, because sometimes customers or emitters come with good technological ideas, and then there's no category yet, and then they have to wait for 1 or 2 years before this category is researched and implemented into SD++. So that's a challenge. And also there is a kind of automatic ranking in who gets the actual subsidy, as it's a competition based on the amount of subsidy you need per ton CO₂. So the less subsidy you require to cover this cost gap between emitting and applying a certain decarbonization method. That can be CCS, but also electrification or heat or anything else. The less you require, the higher you rank and the bigger the chance that you get CCS. So this, or SD++, sorry. So this way, the subsidy scheme makes an automatic ranking based on cost effectiveness. And then certain categories are excluded, but most categories can apply. Yeah.
Okay, thank you very much. And following this question, Sarah, I have another one for you. It's a little bit more technical, I guess. And the question is how Porthos and Aramis handle the impurities of or from different CO₂ sources, and other published tolerances are final. And another question is who is liable for the purity of the CO₂?
Okay. Yeah, maybe to start with the first one. So Porthos came up with a standard in terms of purity that worked for the whole Porthos value chain. And now, of course, Aramis is added to that and also makes use of the landline of Porthos. So you need to work towards one standard as all the CO₂ will be mixed. And because Aramis uses a dense phase offshore pipeline, which increases the chances on corrosion, they are looking into what should be the required CO₂ spec in a joint Porthos-Aramis task force. The research is being done right now. I don't think the results have been published yet. And of course, it's also a trade-off all the time between the costs that go to the emitter to reach this purity and also what is possible in terms of coating or technical solutions. So unfortunately, no final answer yet, but I know that they are working very hard to come up with a standard that works for everyone. And then, of course, it impacts the business case for the emitters. So some of them, it's quite easy to reach these purities, and some, such as waste, it will be a challenge to reach it. So hopefully, the government can also support a bit in that new challenge.
Thank you very much. And now I have a question that I find quite interesting. It's to Fluxys and to Gilles and to Sarah. The question is if there are any CCU companies connected to the planned pipelines. Is there special cases for that, or do you not plan this right now? And this is something like for the middle term.
Yeah, so I mean, the regulatory framework in Belgium does not make a distinction between CCS or CCU from a CO₂ transport point of view. So we are building out a network on which everybody can indeed attach. We currently see in the market that, of course, CCS is much bigger. So the CO₂ volumes from a CCU point of view are much smaller. And currently also with regards to the network development, I do not think there are any projects yet that are looking at CCU to connect to the CO₂ transport network. There is, however, in Wallonia, there is a project of CCU, but then it would be with a direct pipeline, I think, between the two emitters. But yeah, so that's also definitely something that is for us a consideration in the long term, I would say, that you have a system where certain emitters put their CO₂ in the network, which is subsequently used by another emitter also attached to the network to use as an input. Yeah, but I would say that today it's rather a marginal phenomenon, but we do expect this to increase in the future.
Yeah, maybe I can add to that. I think we have a very interesting project, which is actually already operational for quite some time in the Port of Rotterdam. It's called OCAP. It's a pipeline from the Port of Rotterdam to greenhouses in the north of Port of Rotterdam. So the greenhouses use the CO₂, industrial CO₂, to make our food grow faster. And it's already working. And it's going to be connected to the Porthos landline, and there will be customers who half of the year supply their CO₂ to the greenhouses because they only need it in summer, I think. And the other half of the year, the CO₂ goes to permanent storage. So indeed, it also always feels like a long-term thing, but on the other hand, it's the first operational CO₂ transport that we have in in the port of Rotterdam. And for more industrial applications, we do see more and more requests also asking us, like, are there any biogenic CO₂ sources in the port of Rotterdam? And we are still researching whether it would make sense to have those CCU parties connected to the same pipeline system. We make sure that everything built now, it's possible to make tie-outs as well, as Gilles also said. But for instance, if they need lower purities in terms of specs, it might make more sense to have a separate, maybe by truck or co-siting even, infrastructure than using the same. So, but very interesting development, I think, yeah.
Thank you very much. And Kai, no worries, I have some questions for you, but another question for the pipeline gang. There is another very interesting question. It's about Widerstandsfähigkeit, resistance of the infrastructure. So, if there are any thoughts about the global security situation, and if the CO₂ pipelines are categorized as critical. So is there any thoughts about this, any plans about this? How do you get the security situation on track?
So I think resilience is indeed very important, but you are confronted with the challenge that it's a low margin business. Let's be honest, CO₂ is a waste, so it means that it's quite difficult to build out a cost-efficient network that allows emitters to competitively decarbonize, which also means that you have to be very careful, or you have to really think through the network you want to build, because the more resilient the network becomes, it also implies you have to build more pipelines, which makes it more costly. So I think that's always the equilibrium and the balance that needs to be found. But I also want to link it back to another discussion that already took place with regards to the liabilities, who's liable for whatever. For me, it's definitely linked to this, because what we do see is that definitely from an emitter point of view, there is definitely concern to take FID before there is a clarity on the division of liabilities. And for that, we definitely also see an important role for the government, because of course, there is kind of a risk, definitely in the startup phase, when your system is a little bit smaller scale and as a result, less resilience, where a certain emitter might have to vent because the value chain is down, or the transport infrastructure is down because of a problem at the storage site, or a problem from another emitter. And then the question becomes, how do you solve this issue? Because in such a case, an emitter would have to pay for ETS, but he would also have to pay for the capacity booked on the transport infrastructure. And we do hope that we can talk with the governments. This is also perhaps a message for you, to really take this into account, because I have the impression that not everybody is aware of this issue. But it's important that we engage with government to look how we can tackle this issue. And for example, get an exemption on ETS, or have a guarantee mechanism that allows emitters that have to vent, even if they're not in the wrong, to make sure that they don't have to pay for this, because then there would be a double penalty for them, which of course also impedes the kickstarting the whole CCUS value chain. So for me, this is definitely in the beginning of the network development, a very important issue, which probably over time will become less of an issue, because then there's more expertise, the network becomes bigger and more resilient as a result.
Thank you very much, Gilles. Sarah, do you have anything to add, or?
The liability point is definitely something that, especially if we go to like a cross-border network, right? It goes through the value chain, all those liabilities that we come up with, maybe even European guarantee scheme or something, especially in the beginning, to cover these risks. Yeah.
Thank you very much.
Yeah.
So, Kai, I have some questions for you. The first one is already very technical. It's about the required specification of the CO₂ for your floating storage units. Can you say something about that?
I can try to answer that a little bit in general. I mean, as I said before, we are able to handle various specifications depending of what kind of capture technology or capture process has been used. There will be different qualities, also the mode of transport. But in the end, we will be able to handle CO₂ purification processes that are most common. And we do anticipate that there will be some CO₂ specifications also coming from the grid operators, especially if transported in liquid form, to tackle challenges in terms of corrosion and stuff like that right away. And we are very confident that we can take on different kind of qualities at this point. If it's something very specific that's being asked for, I may as well look into that in a bilateral discussion with pleasure.
Thank you very much. And there's another question to you, Kai, and it asks, how does the injection part look like? It's a floating installation similar to the one collecting the CO₂ before transport. And do you already have potential customers for transport by the ship, since you said pipeline transport remains an important option? So like 2 questions.
Yes. So of course, pipeline transport is important, especially inland for us, because I mean we are starting our operations in the port. So that means for large scale volumes, we would also require pipelines to go into this port, so we can connect them to our floating storage unit. The injection itself will be done directly from the shuttle carriers that we have. That's done via a so-called offshore mooring system. So when going down to the storage field, the ships can kind of hook up there and using this single anchor loading system directly inject into the subsea surface. Subsea, there is a little bit of a distribution system to transport the CO₂ to the different wells, but in general, what we are doing, I mean, we are conducting these operations on sea to subsurface. And in terms of transport or customers, we are of course engaging at this point with various emitters, with aggregators, with various ports to get these solutions online as soon as possible.
Thank you very much. Yes, we have a few other questions, but because of the time, I think I need to go on. If there are any very specific questions or emergency questions, just write me an email and or write an email to the speakers. I think we will handle and manage your questions. So my last question for you guys, it's a more global question, and the question is, how do you see Germany or Germany's role in your projects? What kind of role is Germany playing for your activities, for your future plans? Could you give me just a short view from your side? And let's begin with Sarah.
Yeah, I think we definitely see, maybe more even the other way around, the role of the Port of Rotterdam as an important exit towards storage for Germany. And then I think even through the Fluxys line or Gasunie line, that we are preparing to make that connection work. But then, of course, in Germany, we need the right policy and regulations to also enable emitters to start investing in CCS. But I believe that the surrounding countries are doing a lot of preparation work to make sure that we can offer a decarbonization solution for Germany as well. But yeah, policy and the London Protocol and everything should be there to get started. Yeah.
Thank you very much. Gilles, please.
Yeah, well, first of all, I agree with all of the above. So I fully agree with Sarah. So indeed, we also offer exit options to Germany. We do hope to see some evolution on the regulatory framework, on the London Protocol indeed. I think an important remark perhaps to be made is, I think it was also in Sarah's presentation, so the difference between the first projects versus large-scale development of CCUS. So I think it's safe to say that the more volumes you can aggregate, the more competitive and cost-efficient the whole system comes. And then from that point of view, of course, it makes a whole lot of sense to try to aggregate as much as possible volumes from different member states and countries. And of course, I think in Germany, CCUS definitely has a role to play for the decarbonization of the industry. And of course, that would offer quite some volumes, which combined with Dutch and Belgian volumes might offer very, very cost-effective transport solutions.
Thank you very much. Kai, your last sentence?
Yeah, I mean, very much agreeing with that. I think Germany plays a very important role. I mean, first of all, because there are a lot of emissions here. And secondly, there are very ambitious targets to get rid of it. And of course, I mean, we all are offering solutions, for the exit of CO₂. Nevertheless, we are all but one piece of the puzzle. And it is important, that all the pieces, come together at the right point in time. To make this entire system work most efficiently and effective from the get-go.
Thank you very much, Kai. So now I have to switch to German. Vielen lieben Dank. Thank you very much, guys, for your presentation. Ihnen, liebe Zuschauer und Zuschauer, ganz herzlichen Dank fürs Zugucken, für die Kommentare, für die Fragen, und wie gesagt, sollten im Nachgang noch drängende Fragen bestehen, gerne an mich oder an die Referenten direkt wenden. Dann war es das auch für heute. Dann wünsche ich Ihnen allen eine restliche, schöne, erfolgreiche und vielleicht auch sonnige Woche, und wir sehen uns dann nach den Sommerferien, nach der parlamentarischen Sommerpause wieder hier bei uns im Energiestudio. Vielen Dank und tschüss.